All right, on chatting, what is your conclusion? Right. Yep. So, okay, here we go. Yeah. You see it? It's going to be, right? Because once you add, think about it. You think about why this one has to be true. Think about u plus v first, and then add c. I mean, right? How about a plus adding b and c plus? I mean, inside each coordinate become real numbers, and they have to obey this rule, right? Because x coordinate, y coordinate, z coordinate must obey this rule, isn't it? Yeah, true. So you may say, who care about this whole little thing? I think we have to care about it because they're kind of trapped with rule for future argument here. Look at this. All this guy, see where we're heading, right? That's where we're heading to. Then we're done with the course. We'll obey this rule. So association property works out in addition. How about number? All right, everybody. 1, 2, 3. Type the answers. Number 3. Type the answers. All right, everyone, come on. Yeah. So this is an association property going to work out. Prove it. You actually do it just like this. Yeah. I mean, if someone asks you adding it, I don't know. How do you prove this guy here? A sub 1 plus, right? A sub 2, A sub 3 plus 0, 0, 0. I mean, it's so obvious, right? Right? If someone asks you this kind of proof, then you says, okay, I show you, what do you call this? This is a real number now. X coordinate is a real number. Y component, that's a real number too. So, right? That's what 0 does. Yeah, so you could argue something like this. Okay. All right, everybody, number 4, get set. Number 4, oops. Type the answers. Number 4, come on. Using your intuition, okay? I guess you have to use all this, like, see how it goes, right? Yeah. It's so obvious, right? Yeah. Right. I mean, so interesting is it's really acting like a real number. It's something like this. I don't know. It's like you think about this. Uh, for example, like force is what? Force is ma, right? You think about you're pulling here, force going this way. Negative force is going this way. You add this to what do you think you're gonna get? You get 0, right? What does that mean? It's not moving. It's not gonna move, right? What is the acceleration? What is acceleration? Change of velocity over change of what is the acceleration? Isn't it velocity, change of velocity over time? You're not even moving. There's no acceleration. It's 0. That makes sense. If you understand my argument, type yes, please. Yeah, how about force plus negative 4? You're not moving. Acceleration is equal to 0. Force is ma, it's not moving. All right, force equals 0. Something like that. Okay, so I guess think of this one. So far, we did all these properties in scalar, right? Number, right? Number, we know that number, commute, right? Association property. I guess we're repeating this argument using same factor. We're kind of following. How about vectors? Do they follow that kind of rule? All right, everybody's 5. 1, 2, 3. Type the answer for number 5. So we're kind of, see whether this guy's acting like a number. Yeah, it is. Is it? Yeah. All right, someone has a microphone is on. Turn it off. I mean, only turn it on when you ask me questions. Otherwise, we hear you, all of us. We know what you're doing behind the screen if you turn on your microphone. So we're not interested by your privacy, so don't share your privacy, okay? Yeah, just turn it off. I'm just kidding. Yeah, just turn off your microphone. So yeah, I mean, we could prove this one algebraically, right? I mean, it's so obvious, right? I don't know how. Here we go. Here we go. C u plus v, right? C. I mean, I think we have to do a sub 1, a sub 2, a 3 plus. Yeah. Process this in your brain. Okay. I mean, this is kind of too much. A sub 1, a sub 1, a sub 2. See what it takes here. A sub 3. But you already know all this stuff, right? And then what do? We start to multiply this guy's what? C a sub 1, b sub 1, C a sub 2, b sub 2, C a sub 3. Yeah, something like that. You sense it, right? You sense this one. And then what do? Gosh. So real number distribution property works out, right? Now it's a real number now. So C a sub 1. Watch how much it takes to writing down all this. So much. Right? If someone asks you, write down this much, okay? Someone says, hey, show me, then okay. Right? It takes forever. I didn't know that it takes this much. Did you know this? It takes this much? Crazy. Yeah, you do that too. Here, then what do you do? Okay, what's the next line? What are you gonna write down? I'm just proving this one. Okay, what do you think? Just type it up. Type it up. What do you think I'm gonna write down? Next line. You write down. All right. On chat, write it down. Also I'm checking your attendance every day. I just take the picture on your participant list, and then yeah. Please write down on chat. What do you think we can write down to complete this proof? Okay, I got a picture of all the participant list. Okay, so let's see. Let me see what you wrote down here. Yeah. I think you should write down something like this. We have to get to here, right? We have to get to. You think about it. You have to get to C. That's what you try to get to, right? That's what you try to get to. What do you think you should write down here? Is it nice? Yeah. Then you say this. What do you think? Yeah. What do you think? Yeah. Good proof. So even this one, say the thing takes so much, so much energy. Here. So I did C and then this, and then write down this guy to this, right? And then we finally distribute the number, right? And then inside here, it's a real number. So association properties, distribution property works out here, right? And then you finally split them, and then you kick out C out of the vectors, and then you get it. Make sense? Think about this. Suppose this is what? Suppose this is the vector u. Suppose this is vector v. So that Okay. How about this? Let's say this. Let me make u plus b. This is u plus b, right? U plus b. Let me make this guy double. Double, like 1, 2. This is what? This is what? Yeah, this is 2, right? Whole blue is what? 2 of u plus b, right? Isn't it? Yeah, this whole thing, right? How about I do say this is what? This is 2u, 2u, right? I do, right? I w, and let's see. This is what? This guy become 2v. What do you call this guy? You call this 2u plus 2v. How's that, huh? If you understand what I'm doing, type yes, please. Type yes, if you understand it. Yeah, that makes sense. That's what it says. What did you get about u plus v and double it? Or double u, double v and added. They're the same thing. Something like that. Yeah, okay, I get it. All right. So again, I want to emphasize why do we have to think about this silly thing? This silly thing is a grammar for our entire course, right? Look at this. Just check out again. I'm just emphasizing we're going to go to dot and cross and then to 13, 14, 15. Then we're going to hit this big topic, work and flux. It's all about vectors. Why work and flux? We're talking about energy, our survival. We need energy to survive. We need to know how to generate the power. It's all about work and flux. Basically, physics 1, A, B, C, D. Okay. All right. So that's what we're getting to. The purpose of Math 220 is in the course of studying physics and then engineering, it's a primary tool. I'm asking you, think of this. I say your mission is this. Okay, this, how about this? Okay, your job is dig the ground, dig the ground. Or I'm asking, hey, why don't you dig the ground? This is like physics, and then this is like physics and engineering. Okay, engineering. So think of this is your job. Your tool, right? Shovel, math. If you understand my analogy, just type yes, please. Type yes. That's what I'm trying to do. You try to solve real life problem, digging the ground, physics, and then engineering. I mean, you could use your hand. You could just use your bare hands and digging the ground. But don't you want to have a very effective tool? That's math 220. That's my job, helping you how to use the shovel. Okay, that's a math 220. Oh yeah. I get it. Okay. All right. So let's move quick. Okay. So now we kind of understand it. All right. Okay. I get the point. All right. So I just want to say why this silly argument is important, because this whole course is about blocks and work. We're going to continue to use vector, and we have to know about the vector first before we play our real game. Everybody, get set, go. Type the answer for number 6. Now you understand how things are going. Everybody, type the answers. Yep, and then You understand it, right? You know that when you add this C plus D a number of times, this is what? C plus D times basically, and then what? You know, A1, A2, A3, right? You know that if you work this out, right? Right? You're gonna end up getting, yeah. Do you feel it? You need to feel it. Yeah. Yeah. Christopher, write down write down C and D first, and U later. And C and D are a number, okay? So write down C, U. Look at the what Vanessa wrote down. Vanessa and then Leonardo, and then Ian, James, you know, Kians, Kayla, everybody wrote down correct answer. Yeah, that's good.
Quick
Good job,
question.
everybody. Any questions?
Quick question.
And your name?
Justin.
Uh-huh.
So when you write A1, A2, A3, that's just really vector U, and A1, A2, A3 is that like X, Y, and Z?
Yeah, that's right.
Okay, just want to
Here.
make sure.
Here, Justin, here we go. Here we go.
Mm-hmm.
Check this out here. So when we say this, what is A vector is what? It's like our case we use the letter U, right? Sometimes it's
Mm-hmm.
A. Look at this. That's A sub 1, A sub 2, A sub 3. Make sense?
Right. Okay.
Okay, everybody. So this one too, associations, you know, association multiplication. You know that it's gonna work. Right? You know this. Right? I mean, it's the same thing, right? You actually do it. Yeah, it's so obvious, isn't it? What if you prove number 7? Okay, you prove it. I'll wait. You prove it. Prove it. Start from the start. Cut right this. You somehow logically end here. All right, that's what proof is. All right, take a minute. Show me your work. All right, do your work. Yeah, Justin, on your chatting, put the addition sign, okay? I know what you mean, right? Yes. You mean CU plus CU, right? Good job. Okay. Everyone got it? Yeah, so it's kind of obvious that, you know, we get this what? CD A1, right? And then CD A2, A sub 2, you know, and CD A sub 3. Yeah, and then what do? We only kick out C out of it, right? Yeah, yeah, and then C, then DA1, DA2, DA3, right? Yeah, and what is this guy? This is what? C and then what? This is DU, something like that. Isn't it? Isn't it? Yeah, it's obvious. Number 8. Everyone write down the answer for number 8. 1, 2, 3. Answer for number 8. Everybody come on, write it up. I know you said duh, right? Yeah, you said duh, right? But this becomes very important concept in math 7, okay? Right, so that's why we write down this kind of thing. Okay, there we go. Number 9 and 10, this is it. Number 9 and 10. Number 9 and 10. Number 9 and 10. Number 9 and 10 is this. Yeah. Yeah, this is important. This guy is now, it's not funny anymore, okay? Could be. Okay, this one is not funny anymore. So what is the magnitude of U? All right, everybody, type it. What is this? Length. Length of the arrow, right? Yeah, so we know that. Back to the V. Length of the arrow. All right, so we get that, right? So number 9 is about this. How about I multiply number C? Can I write down this one in terms of, we love to recycle. I want to write down, how about this vector C here, Like here, my vector U. How about vector C here, CU? What number do you have to write down here? Everybody, 1, 2, 3, type the answers. What is the answer for this box? What are you going to write down this? Square root of C? Okay, everyone, come on. Square root of C? You surprise me. You're all wrong. C? Okay, seems to be getting better. All right, Cameron. All right, Faria C. Okay. All right, so we do this, Okay. C ace of 1, C ace of 2, C. Oops. Take your time, People who say square root C, you ignore algebra 1. Yeah, so here we do, we do C ace of 1 square, C ace of 2 square, yeah? C ace of 3 square. Yes? What do you know? All right. So I want to ask you one more time. Everybody, ready? Get set. Ready? 2, 1, 2, 3. Type the answers. Everybody, come on, type it up. Come on, everyone, type it up. Type it up. Type it up, everybody. Okay. Okay, so you guys are all wrong again. Do it again. You are all wrong. Type it again. What goes in this score? This blue box? You're all wrong. Okay. Now we start to see the correct answers. There's no such thing as plus minus. Alejandro, when you have something like something square, you cannot say plus minus. You're confusing between this one, x squared equal a kind of thing. That's a different thing. Aha, well, that's scary. Wow. When algebra is kind of, yeah, that's right. Kayla, that's correct too. All right. So when algebra messing up, this couple of things here. Alejandro first. Alejandro, don't get confused between these two. 9 and x squared equal 9. These are different questions, Alejandro. What's this? This is called 3, plus 3. This is called plus minus radical 9. X equal plus minus 3. Alejandro, does it make sense? This question, different question. Yes or no? Yeah. You watch out this kind of basic math, okay? Yes. That's one thing. Okay. People says that c squared equals c. Let me follow. Let me trust you now. Okay. I'll trust you. So since I trust you so much, I'll follow you exactly. You say c equals negative. So according to your formula, I have to write the negative 3. You're lying. How come radical 9 is a negative 3? This is a lie. Don't lie to me. You mean this. So, okay. Define this. Now you're a math 220 student. I know you're gonna have a lot of algebra students. You need to know this one. You can't do this kind of thing in algebra class. Okay. I mean, this kind of course. What is this? Absolutely. Be careful. Why is that so? You want What if C goes? What if okay? C is a two in this case. What if you say this is what? How about C is going this way? How about C is like going this way? How about what if C is negative two? You're gonna say, oh wow, length of this guy is what? You're gonna say, wow, magnitude of negative 2u is same as what? Negative two times u? You gotta be kidding. That doesn't make sense. You mean this, right? You mean it's a double length of this guy, right? Right? Yeah, it is double length, isn't it? You don't say negative to length. That doesn't make sense. So watch out this. If you understand my argument, type yes, please. All right. So we're not gonna fool by this kind of thing, little thing. Yes? All right, good. So yeah, so just watch out little algebra. Just watch out algebra. Okay, how about this? So number 10 was what was this? All right, now let's see who got the answer for this. Use your geometry, okay? Use your geometries. All right. Write down something. 1, 2, 3. Where's my chatting goes? Okay. All right. 1, 2, 3. Type the answers. What goes in this green box? Okay, everybody, type it up. What goes in this green box? Number 1 equal. Number 2 less. Number 3 greater. Number 4 less than equal to. Number 5 greater than equal to. Okay. All right. All right. Let me ask you, what is the number? 1, 2, 3, 4, 5. One more time. What is the answer? Type it up. His answers are 1, 2, 3, 4, 5. Okay. Type it up. Everybody, come on, type it up. Get them both. Yeah, give me the answers here. Which one do you gonna write? Number 1, 2, 3, 4, 5. Which one? Yeah. All right. Come on, type the answer. I'm keep drawing. Type the answers. What did you learn in geometry? Use a geometry. This case, think about this. You know what this one? That means it is just simply triangle. Did you just adding two sides always larger than third side? Okay. Vanessa, what's this? Of course, they're not parallel, then you're going to make a triangle. But what if they're parallel, Vanessa? Are you learning something? Okay. It's pretty fun, huh? Isn't it interesting? Huh? Yeah? Vanessa, what's this? That's simply the length of this guy. Adding vector mean that doesn't mean always making triangle. If they're parallel square line, and so this time what happened? It's basically u plus v, right? What do you say? Well, how about the length of those? Aren't they the same? Same, right? If they're parallel, they're same. Otherwise, what happened? One side is always less than equal to sum of these two. So answer is what? 4. Physical triangle inequalities. Right? Isn't it? Yeah. Think about it. If they're parallel, they're same. You add this one, that's u plus v, and they're same. Length of summation, length of each one, added, they're same. They're same. This time they're same. But they're not parallel. If u and v are not parallel, you're gonna make always triangle. Of the two sides are always larger than third one. Of course, you're here. You think about it. You walk straight to here. This is ECC. It takes less time than going. I know that too. Got it? All right, you're my guest. If you understand this lecture, type yes, please. Let's see how many of you understand this. Fun? So, I promise you, you'll understand me every lecture. Just come to lecture, okay? You will have a good time. You will get it. No, it's just like that. It's not so bad. All right. Okay, so wow. Here you go. So let's fill this in. Let's move out. Okay. So again, why is this silly thing? Because it's a feed. This 12 point is a feeder for dot product and cross product, which are crucial weapons for this whole course. But absolutely, don't forget this. When C is -2, don't say -2 times this. Think of this as a triangle. It's the triangle, and then I think you could say, right? It's always this, right? Yes. Don't forget this one. Yeah, so there's nothing to memorize. Understand it. Understand and feel it. Don't try to memorize this kind of thing, okay? Just feel it. Oh yeah, that makes sense. Move on. Okay. Unit vector. Length 1, right? What does unit vector mean? Unit vector mean length 1. Unit vector mean length 1. Length 1. Okay? Length equal 1. So here's a vector V. All right. This is the ABC. Suppose it's not a zero vector. It's not, All right. Why don't you find a parallel vector? There's so many length 1. You know how to do the length 1? This is how you do the length 1 here. Length 1. 1. 1. 1. 1. 1. 1. Oh, you mean length 1, you mean something like this here. Length 1 and then, right? Oh, my clock. I see my clock, length 1. My clock's maybe minute hands, going around. That's length 1. So this is what all the vector length 1. If you understand this, type yes, please. If I say describe all the unit vector, just draw the circle and then just put this whole bunch of arrow. That's all the unit vector in the universe. Why? Location doesn't matter. Draw the unit circle and put this arrowhead, this minute hand, whatever. These are all vectors. So among those guys, among this all vectors on plane. How about in space? What is all unit vector in space? Tell me, how do you describe all vectors, all unit vector in space? How about in space? How do you draw those? What do you think we should draw? If I ask you, hey, why don't you draw all the way in space? Here, Justin is correct. Hey, why don't you draw all the vector? I say length 1, right? If you understand Justin's argument, type yes, please, everybody. How about space-time? Space-time. Space-time, I guess here in space, and then, I guess even this vector, if you use space-time, it's just the same location, but different time. Then, yeah, all the vector of plane, unit vectors was circle, space basketball. Okay, folks. I give you this vector. Why don't you find a vector parallel to this guy, which is length 1? All right, you write it down. What is it? This is important, guys. Some vector parallel to this guy, but length 1. I don't know what this guy's length is. I mean, this if this half, length has to be what? If this half, then it should be this much. If this is like a 2, then it should only this much, right? Make sense? All right. Give me the equation. Why don't you work it out? Find the equation for all the unit vector, length 1 vector, parallel to this guy. What is it? Let's see who gets the answers. First of all, how many? Tell me, how many vectors are parallel to this guy as a length 1? 1, 2, 3, type it up. How many vectors? Okay, everyone type it up. Are there only 1? 2? Okay, Troy. Wow. Good. More than 2 or less than 2? What? Infinitely many? Matthew? Infinitely many? But what's a parallel? Parallel mean? I mean, if for example like this, is this guy the parallel? You're out. You're not parallel to this guy. Parallel. Baron. It cannot be infinite. You know that. I mean, you have to parallel. I know they're infinite many vector, but unit vector, but they're not all parallel. I'm pretty sure here. Here we go. Can I show you this? Oh, let's draw this guy here. I know what to do. Oh, here, let me hunt it. You. Parallel to this guy, yeah? And another one. You. There are 2 guys. This guy. There are 2 guys. 2 guys are parallel to this guy, isn't it? Yes? There are 2. There are 2 of them. So Mungjins, change your answers. There are 2 of them. Yeah, direction doesn't matter. You're right. That's the point is, we thought that we were talking about heading the same direction, but how, you could go the opposite direction too. That's what parallel meant. Yeah, give me the equation. The equation is this. Why don't you get the magnitude of this guy? What is the vector parallel to this? Okay, let's this. All vector parallel to V. You know how to write on this? Okay. Please write down all vector parallel to V. Type it. Something. Give me the equation for vector, all vector parallel to V. Type it up. What is it? Then let's talk about the length later, okay? Okay, give me the equation for, expression for all the vector parallel to V. I'm just talking about this guy, this guy, this guy, and then this guy, everybody. All right. How do you write down this? First of all the vector parallel to V. Remember, that's good. That's for you're getting to unit. But first of all, give me the vector parallel to V. I'm not asking you unit vector, any vector. Any vector parallel to V. How do you write in this? Just say CV for any C not 0. If you understand my argument, type yes, please. Positive C면, yeah, you're in the same direction. Negative C면, yeah, you're going down direction. You guys are all parallel vector. You make it double, triple, negative 3, negative 4. Okay, all vector means CV. Okay, where C is not equal to 0. Okay, that makes sense. All right, now then let's get to our question. Among those guys, I want length 1. Length 1. Just in Cmin, it could be 2V, it could be 3V, right? It could be negative 4V. What happened? This guy, if V is what? If V is this much, how about 2V? 2. How about 3V? 1, 2, 3. How about negative 4V? 1, 2, 3, 4. Does that make sense, Justin? Yeah, any number, like 1.7, whatever. Yeah, it's like extending it. Armando, yeah. Transformation? Could be, yeah. Transformation usually moving around, right? Armando, vector case, location doesn't matter. So now we got this. Yeah. Now let's get it. Now let's hit this guy. Let's move out. Okay. Now I want to ask a question. Give me the length 1 vector parallel to this guy. A lot of people write down the answer there. Okay. We claim just divided by length of this guy. This one is what? First of all, we gotta check this. Parallel? Are you parallel to V? Look at this. That this is some number. It is a parallel. Yes. Yes? Because it's a number. If you understand this, type yes, please. Okay. You gotta check 2 things. Are you parallel? Are you length 1? Are you length 1? Length 1? Question mark. How do you check length 1? Oh yeah? Here we go. You find your length. I think you learned something very important. Yeah. Kick out the constant. Yeah. Yes? All right. So now here, I'm gonna kick out this green, Hey, you're my C. Hey, my C. You're my constant. All right. I'm gonna put absolute value on you, see? Because your number, you're some number, length, right? Okay, vector V. All right, here's a crucial question. Okay, this is the question, folks. What is this code? What is it? Oops, I'm sorry. I forgot the what? Putting the what? Absolute value, right? Sorry here. I forgot that putting absolute value here, right? I forgot to put in absolute values. And magnitude, right? Here. What do you know about the magnitude of this guy? This guy's always positive. I mean, if this, I said not 0, right? Yes? It is positive. What do you think the absolute value of positive number? What is the absolute value of positive number? Itself, isn't it? So we don't need an absolute value. It's just simply the same as I don't need absolute values because this guy is a positive, This guy's positive. Length 1. If you understand this, type yes, please. Unit vector means just simply divided by your own length. Vector divided by length of the vector. You're going to be length 1, obviously. I'm so glad you understand it. This is an important concept. I see this guy, this silly argument appears so many times. Whenever they say vector parallel to this guy, just simply say, vector divided by length of this guy, you know, your parallel and then your length 1. This guy? How about this guy? Yeah. If you understand this type, yes, please. This guy is yeah, vector v divided by length. You okay? How about vector v divided by length? Go opposite. Yes, very important concept. Please remember, digest, understand this concept. Okay, important. So far, so good. Can I move on? Yeah. So turn out to be here in space. Something parallel to this. There are two guys. Here we go. There's so many. There's this guy and this guy. That's this guy and this guy. You know, there are only two guys parallel to this guy, V. All right, let's go. Let's go. Okay, here we go. Finally, oh, then we start with something maybe real math. You know, let's start this. Okay. It looks like, you know, I think Troy, we need two of them. Troy, I think we need, what's that? I asked you to find the two of them, right? All of them. One of them is what? This guy. The other one is what? The negative, right? We have two of them. So we need plus minus two of them. This vector is what? Heading to the same direction. The other one is what? Heading to the opposite direction. Negative, right? Isn't it? So divided by length, you know. Yeah, length 1, you're parallel. But let's put the opposite side too. You know, you could go opposite way, negative. All right, so let's do some. Oh, okay. Now it sounds not big to me. You know, how about this? Okay. So what is a Newton here? You know, force is what? Force is what? Ma. Right? So this is what? Kilogram. Something kilogram times. What is it? What is the unit here? Kilogram times meter per second square, right? We call this what? Newton, right? This is the force unit. So we define this. This is SI unit. Kilogram times meter per second square, we define as newtons, right? So 1 Newton is something like how much force? Think of, you know, you go to store. 1 Newton is about this. 1 Newtons. Yeah, this is what? Newton, right? We on 5 Newtons. So think of this. You go to a store, grab, go to store, grab it. The force unit is right? So it's grab a typical apple and then lift it up. Then you feel the feel. If you understand what I'm talking about, type yes, please. The force you need to lift the one apple, you know, Mr. Isaac Newton. Oops, apple drop, you know. So get a typical apple, you know, kind of lift it up, you know. That's about 1 Newton, you know, kind of. Anyway. So it's like a lifting of 100 apple, you know. Force you need it. All right. Yeah, about that. So supposing we have this, and then, you know, string is what? Holding, what happened? You know, this guy want to go, right? Gravity, right? Gravity, right? Yeah. And then they're not moving. Equilibrium, what happened? The summation, say this is like, let's say this is like a, you know, let's say tension. This is like basically force 1. Tension is what? Force, right? Tension, how tight the string is, right? This is the force 2. Think of this. This guy, say this guy is what? Weight is what? This is, you know, force 3, you know? Think of that way. So what is the force 3 here? This one is, I think, magnitude of the force 3. That's what? 100 newtons. You know? The force is, well, this guy did. Let's think of this way here. This is, let me do the coordinate here. This is x-axis. Say this is y-axis. So I think this is typical what method. It's a physics 1A problem, isn't it? Right? Isn't physics 1A? This one, kind of. Yeah. Question. So here, think of this. What is the coordinate for this guy? This guy is, I think, x coordinate 0, y equals what? 100, right? Something like this. Isn't it? Yeah, then that makes sense, isn't it? Right? It's going downward. Yeah. So let's find out what is the F2, F1 is. F2 is, what is the x component? First of all, magnitude of T1. And what is this angle here? When two lines are parallel, what happens? When two lines are parallel, what happens? Alternate interior angles are the same, right? What is this? This is what? 30 degree, right? Isn't it? So the length is this. So what is this one? This is basically what? This is what? Magnitude of T2, and then what? Cosine 30, right? I, right? Isn't it? Yes? That's this force, isn't it? If you understand this, type yes, please. All right. This is what? Magnitude of T2, what? Sine 30? Sine 30? Sine 30, right? Sine 30. Sine 30 is, I mean, you know what I mean. It's something like this. You have like, A, and then here is a 30 degree, and then what is X? X over A equal what? Sine 30 kind of thingy, right? So X equal A sine 30, whatever, right? Yeah, kind of this kind of thing, right? So, A case is what? Magnitude of T2, and then we know this is like a J component, right? Makes sense? So what is this vector? This vector T2 is what? This plus this vector, isn't it? So here, how do I write this? Cosine 30 magnitude. Yeah, here is this guy. Here is this baby question. What's this? T2, T1 sine 30, right? So which is, let's work it out. What's that equal to? Cosine, radical 3 over 2, T1. 1 over 2, T1. Any questions? That's what, that's it, right? Yeah? Yeah? That's what this, that's this. You add this plus this, that's called T2, right? Vector sum. Yeah. Yeah. Where did you get 3 over 2? It's not 3 over 2. Cosine 30, Justin. Square root 3 over 2. What is the cosine 30?
Oh, I see it.
Yeah, that's okay. Sine 1 over 2, right? Yeah. 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 Okay. So far, so good. Let's go to this guy here. Let's go to this guy. I mean, we do the same thing. Okay, so here we go. What is a T? What is this force? T2. Tension is a force, okay? Yeah. So what did you find this guy out here? What's that equal to? 60 degrees? Okay. So let's find out this x coordinate. What's that equal to? Okay, you guys type it. What is that guy? This is what? Magnitude of, what's that? T1. Oh, wait a minute. This is T1. Okay, can I change to here? This is all T2. Sorry. It's all T2. What am I doing here? 2. The second force. How about T1? What's that? Cosine 60? Is this correct or wrong? Everybody? Correct or wrong? Type it up. Correct or incorrect? 1, 2, 3. Type it up. Type the words correct or incorrect, either one. Everybody, type it up. I'm asking you this vector. I'm asking you this vector. I wrote down this. Is this a correct or wrong? Why? How come it's a positive vector? So what do you think we should do? What do you think we should do? We should put negative in the front. Or check this out. If you don't want to think about this kind of negative, why don't you say this is what? Sine 120 degree I. And cosine will take care of this negative. Do you want to put negative cosine 60 or do you want to put cosine 120? It's up to you. Who cares? Same thing, right? What is cosine 60? This guy is 1/2, right? How about cosine 120? Negative 1/2. Beautiful mathematics. It doesn't matter. Do you want to just think about in terms of angles starting from here, 120, or do you want to think about this basic geometry 60 and put the negative? It's up to you. If you understand this, type yes, please. Yeah, it's up to you. You do whatever you want. You're the boss. Okay? You do whatever you want. Okay. All right, we're almost there, you know. All right, let's do this. This guy, please get up. Yeah, I was thinking about covering 12.3 today, but I don't think so. We only have what? I mean, we didn't even start for this game. Okay, so what's that equal to? So it's okay to sine 60, right? Yeah, this one, you clearly see that. Yeah, we could just write down this one as well. Magnitude of the T1 sine 60 J. Right? So what is this vector? This guy is, so what is T2? It is magnitude, yeah, negative T1 cosine 60, comma, T, I mean, it's a positive, right? So J component, I don't need to worry about it. Oops, T1. Yeah, I don't need to worry about it. Sine 60. What's that equal to? Negative 1/2 T1 magnitude. Radical 3/2 T1. Took a while. Oops. So we cut all of this guy. Let's see what we cut. So we cut. Here we go. We got F3. Here we go. Because this is basically what? Negative 100J, right? Isn't it? Yeah? Do you see it? This is simply, what is this guy? This is what? Negative 100J, isn't it? Yes. Yeah, isn't it? Because there's no X component for this guy. So we could write down this one. Yeah, and then where is a T2? T2, so it's in equilibrium. It's not moving. What do you mean? The summation force must be equilibrium means. Yeah, summation is what? You add all the force. K1 through 3. Hey, you're not moving. You're not moving. All right, here we go. Total sum of forces. Why? No acceleration. You know what zero mean? Zero mean basically no accelerations. You're not moving. Change of velocity, change of time. There's nothing happening. You're not moving. So that's why force has to be. Masses are not zero. I mean, so you got to be zero. Not moving.
Wait, Professor?
Yeah.
Isn't that supposed to be T1 instead of T2 in the bottom?
Shoot, I screw again. Oh yeah, T1. Yeah, thank you so much. You're right. You're absolutely right. Thank you so much. I'm getting older. You guys need to help me out, okay? I need your support. I need your love. I need your support too, so that so that we could have a meaningful talk. Okay, so now then, I think mathematics start here. What happened here? So we realize we're adding all the three green, right? Turn out to be zero. What does that mean? Right? What does that mean here? We're adding this guy. What happened here? Let's say T1. T1 is basically x component you added. What do you get? X component, just add x component here. 1/2, right? T1 and the x component radical 2/2. I'm sorry, radical 3/2. T2. Oops. Why just keep clicking that? And then f components that become 0. Right. So how about y component? Y component is again, yes. Why don't you add them all? Radical 3/2 T1. Yeah, take your time. No reason to rush. 1/2 T2. Add the -100 equal 0. Why? Okay, why is summation 0? Good question, Justin. Check out this. There are a lot of forces, right, Justin?
Yeah.
It's not moving, right? No moving, no moving, no moving.
Because there's no time.
Yeah.
Okay, that makes sense.
Just right there. Then I'm moving.
Right.
You know
No.
acceleration? Acceleration means velocity over time, right? Time is changing.
Right.
But you're not moving.
Right. Okay.
What do you think the acceleration should be? 0. So what is the best time 0? Is 0.
Right. 0.
It's not moving. Not moving. No motions. No. Make sense? So you add all the x component, right? Summation of the x component must be 0. Yeah, because it's 0, right? How about y component must be 0? Make sense? Justin? Yes. Sir.
Yeah. Thank you.
Okay. So now, you know where you guys are? It's algebra 1, isn't it? Isn't it like x? It's like x plus y equals something, and the x minus y equals something. Huh? What is it? Let's summarize this. I mean, then I think once we get this, I think we're done. We're done with the math 2, and only thing we do is algebra 1. Now we start 7th grade mathematics. 7th grade. Don't think that's the calculus, okay? It is a 7th grade mathematics to start. How does 7th grade math? Here we go. Let's multiply. If you're a smart player, you should know how to, you to there, you know how to do, right? Yeah, so then we start algebra 1, right? Algebra 1. So using your superpower skill, it's done, Anyone can do this. This is like a joke. But Justin, your question is very important. In fact, it is challenging understanding why summation goes around. Multiply 2, you get 0. Right? Here, multiply 2. Radical 3. Justin, that's why the challenge is of understanding physics. Yeah, that's why only way we can understand it, take the actual physics, understand it, why that happened. Mathematics based on that fact, we express it using mathematical expressions. But people who study physics using mathematics, they are theoretic physicists. Einstein is an example. He was a theoretical physicist. He tried to see the physics through the mathematics. So if you want to understand more about this, take the courses and understand why is that? Why does it happen? And then move 100. So I put 200. I'm pretty sure you know how to solve this. Yes. So let's get it done. Gosh, how do I do this one here? Can I multiply radical? Can I multiply radical 3 here? Radical 3? Yeah. Right. All right. Edit. Radical 3. Add this. Oops. Why this one keep flipping? Yeah, edit. It's gone. What happened? This is what? 3, right? 4. T2 equal 200. So magnitude of T2 equal what number? 50. Aha, one down, one down. Thank you, thank you, thank you. One down. All right, I got one. Phew, one down. Woohoo, woohoo. How about, oh yeah, then just, yeah, what is this? Can I just plug in here? Can I just plug in here? Yes. So what does T1 says, you know? Yeah, saving time, you know. T1 relativity. Yeah, this is what? This is 0. So what's the answer here? 50 radical 3 newtons. And this is in newtons. Oops. Oh, that's the end of the lecture. Okay. If you understand this, type yes, please. Everybody type yes. So magnitude, we did it. Magnitude, we did it. Okay. So how about the tensions? And just plug in. Here, T2 is what? What's that guy? T2, 50? Okay, so this is what? Radical 3 over 2, 50, half 50. That's what? That's what? T2. How about T1? T1 just plug in here. T1. T1 plug in here. Negative 50 over radical 3 over 2. And then radical 3 over 2 times, and simplify, okay? You guys simplify. 50 radical 3. All right. So the answer is, yeah. Is it fun? Yeah. This is what. This is what. T1. Where was T2 go? T2. T2. You're here. T2. You're here. Magnitude. You're here. Magnitude. You're here. Okay. Okay. All right. So now I have to go to next class. Tell me how much you understand my lecture today. 0% mean nothing, 100% mean everything. Everybody, type it. All right. Yeah, so if you get, also, I really encourage you guys come to office hour. Yeah. Yes, come to office hour. Okay, Richard, work on it. Practice several times. Okay. All right. So I'll see you on Monday. So homework is up to 12.2, but I'll collect the homework next week. Just submit that your photo ID of the ECC and then your resume by this Sunday. Okay. Okay, guys. See you on Monday. Bye bye.